Welcome to PRISCI-ANTO Educational Academy. Today I am going to explain you the elimination of arbitrary constants. Here, the notations we have to keep in our mind. Dou z by dou x is equal to P. Dou z by dou y is equal to Q. Dou square z by dou x square is equal to R. Dou square z by dou y square is equal to T. Dou square z by dou x dou y is equal to S. So dou z by dou x is equal to P. Dou z by dou y is equal to Q. This one is we have to keep in our mind. So let us see some examples. Form the PDE by eliminating arbitrary constants A and B from Z is equal to AX plus BY. Given Z is equal to AX plus BY, take this equation number 1. Differentiate equation number 1 partially with respect to x. Dou Z by dou x is equal to AX, x will be 1. What is from the notation, what is the dou Z by dou x? P is equal to A. So take this equation number 2. Differentiate equation number 1 partially with respect to y. So dou Z by dou y is equal to B. Dou Z by dou y is equal to B. Because of B, y will be 1. 1 into B is equal to B. What is the dou Z by dou y from the notation? Q. So Q is equal to B. Take this equation number 3. Substitute 2 and 3 in equation number 1. For A and B, for A, P, for B, Q. Right? So Z is equal to AX, PX plus BY. Instead of B, you have to substitute QY. So which is a required partial differential equation. Z is equal to PX plus QY. In the answer, there should not be constants A and B. Okay. So Z is equal to Px plus Qy. This is the simple problem. One more example let us see. Form the PDE by eliminating arbitrary constants. By eliminating arbitrary constants from Z is equal to AX plus BY plus A square plus B square. So we have to take the given equation is Z is equal to AX plus BY plus A square plus B square. Take this equation number 1. Differentiate equation number 1 partially with respect to x. Left hand side dou Z by dou x. Right hand side AX. If you are differentiating A, BY will be, if you are differentiating with respect to x, will be 0, A square will be 0, B square will be 0. So dou Z by dou x is equal to A, P is equal to A. Take this equation number 2. Next, differentiate equation number 1 partially with respect to y. Dou Z by dou y is equal to B. So Q is equal to B. So therefore, substitute P is equal to A, Q is equal to B in equation number 1. Z is equal to Px plus Qy plus P square plus Q square. Let us see one more example. Form PDE partial differential equation. That is a PDE by eliminating arbitrary constants from Z is equal to x square minus A square into y square minus B square. So given Z is equal to x square minus A square, y square minus B square. Take this equation number 1. That is given in the problem. Differentiate equation number 1 partially with respect to x. How to differentiate this equation number 1 partially with respect to x? This is UV. Left hand side is no problem, dou Z by dou x. Right hand side is there are two things, x square minus A square into y square minus B square. So d of UV is equal to U dV plus B du. So if you are keeping x square minus A square as a constant, you have to differentiate y square minus B square with respect to x, it will become 0. So 0 into x square minus A square will be 0. plus y square minus b square keeping as a constant. You have to differentiate x square minus a square. It will be 2x. So 2x into y square minus b square. What is dou z by dou x? P is equal to 2x into y square minus b square. So P divided by 2x is equal to y square minus b square. Take this equation number 2. Next, the same first equation you have to differentiate partially with respect to y. Dou z by dou y, as I explained you in the previous one, dou z by dou y is equal to 2y into x square minus a square. Q is equal to 2y divided by x square minus a square. Q divided by 2y is equal to x square minus a square. Take this equation number 3. Substitute 2 and 3 in equation number 1. What is the equation number 1? Z is equal to x square minus a square into y square minus b square. So Z is equal to, what is x square minus a square? Q divided by 2y. What is y square minus b square? P divided by 2x. So Z is equal to P divided by 2x into Q divided by 2y. Z is equal to PQ divided by 4xy. So by cross multiplying, 4xy is equal to PQ. So this is the required partial differential